Good afternoon, everybody. I'm going to talk about our Naughty Port project. And this started about around December 2014. We were getting some hits from various DDoSes, and we thought, we need to do this differently. Customer-driven, by the way. So a bit about what we do. I'll skip through this. We do IP registration, transit, provide internet access in data centers. Some consultancy around that in that field, specifically in these following Dutch data centers. All right. So this is the actual issue that we had, and it's interesting that these things tend to come in waves. So basically, at some time it's this customer and then it's that customer, but it looks to be school vacation driven, typically. And the issue is that it's not only on your infrastructure where you get DDoSes. It's actually your help desk. Customers start calling when their lines fill up, and basically they'll start complaining if they have packet loss. Specifically, if you have hosted desktop customers, VPN customers, customers that have gaming infrastructure. So don't forget gamers. Gamers, voice over IP operators, especially those, they really hate DDoS attacks. And they have little to no empathy for the fact that you have a DDoS on another customer, because they simply say, well, just null route them, kick them out of your network. And the issue is, they're going to be up next, the next day. So what do I do with them? And that's where the issue is. Because the issue in itself is not on the transit links, because I pay my transit providers. I can actually call them up and ask them, I got a DDoS attack, we see it in Nashflow. Can you put an ACL to this customer for UDP traffic here or there, and basically make sure that the lines are not filling up and we can actually use the rest of the capacity on the network. And the issue is on the internet exchange platforms. So we were basically looking at how can we filter out DDoS traffic, amplification traffic, most of the time. And see, can we actually look into this? Can we look into where is this traffic coming from? Is it originating from a single source? Is it spoof traffic? So we looked at MAC addresses, IP addresses, matches those up. We looked to see, can we actually do ingress BGP 38? You don't want to know where we got started there. We actually looked to see if we can actually find hardware to actually do, filter that into, the equipment that we had. It stopped at 50,000 ACLs. So, there was no way that we could actually get into something that was workable on that process. And it was actually interesting that the top speakers during the DDoS were actually not top speakers during normal hours. And that was interesting. So if you look at this, this is how the typical internet exchange setup looks like. You have good peers and you have naughty peers. And the naughty peers we define as peering partners on the internet exchange through the route server or direct peers that you typically don't do any traffic with unless you have a DDoS. And that's an interesting definition, because that will actually mean that we can actually take off those peers from that premium link where the green traffic is, and we divert that, then we may have solved the problem on the Internet Exchange. However, in order to do that, you need to understand what we're doing and how they are actually participating in this whole process. So what we did, and this is where the fun part starts. We actually started, a booter site. You don't need to do that commercially. You can do that in-house as well. And you can basically download all the scripts from GitHub, and you need to understand how does this work. So the traffic basically comes from one side, and they send out traffic, to the vulnerable servers, vulnerable devices, somewhere in a network. And then at some point, this spoofed IP address basically gets, the target victim IP address is here, and that's where all the traffic is going from. And if you look at this, you can actually see that certain traffic actually comes from certain countries, more than others. And that is what we were found interesting. So, let's go to GitHub, download some scripts, be a regular script kiddie. And it's actually interesting. It's actually very interesting to see how much of those scripts you can actually find on GitHub. It's actually very interesting. And then you can actually see how those tools are working. You see what they use as input. There's no requirement to scan the whole internet for vulnerable IPs, because you can actually download those as well. There is a search engine called Shodan, and you can actually find vulnerable servers. So per device, per server, per service that you want, you can get lists of IP addresses with all the specifications that you set per country, per AS, per OpenNTP server, OpenDNS server, Chargen service, whatever you like. It's a search engine specifically set up for this. So, and that actually gives insight. And this is what we actually found. During the DDoSes, and after a while, you basically say, all right, we got through it. Now, let's see where this traffic came from. And then we actually started looking at the S-Flow tool set on the M6. M6 actually has a very nice customer portal. They actually provide S-Flow graphs with traffic. And per peer, you can actually see where is that certain traffic coming from. So you can see on your link, you do so much traffic to peer A, so much traffic to peer B, so much traffic to peer C. And during a DDoS, you actually see certain patterns. And we started listing everybody that matched a pattern during a certain time period, typically during a DDoS. So that's how we did it. So this is the specific We Love M6 page. Because we could actually see this traffic here, we actually got the idea on, can we do more with this? So once we actually did the traffic analysis on this side, we then started talking to the M6 NOC and asked, well, can we actually divert traffic from those peers to another port through the route server? And how do we go about that? Can we actually have a naughty list and feed that in RPSL in the right database, and actually have the route server make the decision, I want to include those peers here, and I want to exclude those peers there. So thanks for Eris and Kostas to help us out in this. We then basically, had to do the commercial stuff with the M6 sales team and basically said, we want to test something out. And they offered us the try and buy option at the EvoSwitch data center to basically do this. So this was basically what we did. List the ASs that were sending traffic and basically pair with those on the other side. This is how it looks in the RIPE database. Let me see, do I have a pointer here? Yes, here. So here, through the import via, export via, thanks Job for that, there is a accept here on a specific list. So we pair with everybody on the route server except with the naughty list. And you can pull up the naughty list as we have it today in the RIPE database because it's all public data. So that was the only thing that was basically what it took to get it done. The fun fact was, well, when we were ready to actually do this in production, we knew that AMS had 2 different vendors for the route server. One of the route servers had some issues, apparently, to handle the load of the multiple views, because we were saying we want to have an include here and exclude there. So instead of having a full view, it needed to create different views for different interfaces on our 2 different ports. And that actually was kind of an issue, because this was not just for us. And this was on a Friday afternoon, and we said, famous last words. Yeah, what can go wrong? We can do this. Should not be an issue. All right, so currently M6 is a single route server vendor user because one actually died and it didn't come back. It didn't recover. And we asked the guys, guys, it's not in production yet. We're still testing. Do we need to take it offline? Offload this to the lab? And they said, no. We want to, it needs to be fixed anyway, or not. So in the end, they went through the pain of the TOC cases and those kind of things. And in the end, it was beyond helping them for this. So troubleshooting helped, but the only decision was, kill it. So kudos for the M6 team. The easy option was to ask us to stop it, but they went through it. Okay, so this is the result. So we have the regular ports here, the regular peers, and I will basically say, this is where we do the majority of our traffic. And we have a choke point port here. And the choke point, the naughty port, is basically to pair with parties that have a higher rating, a naughty rating, as we call it. And I'll explain later how we get to that. And we basically do that through a different AS. And you can see that here, because this is a different AS number here than what our main AS number is here. And that has to do with the route server. Because we actually have to tell the route server, we pair with you here on this AS, and we pair with this list on that AS. We couldn't do that on the interfacing, on IP addresses in RPSL somehow. It's probably a route server implementation that's limiting us there. So we needed to do this with 2 ASs. But, ASs are free, so we just requested the second one. So this is where, this is the setup that we have it. And here, once the traffic actually fills up this pipe, it's not an issue, because the majority of our traffic is not here, it's actually here. So most of the customers are not complaining because they don't see packet loss. Yeah? Okay. I'll switch back to this later. Okay. So once we actually had this up and running for about 9 months, we thought about giving this presentation, and we thought maybe we can explain why certain customers or certain peers are on the naughty list. And can we actually predict who should be on the list? Because that was actually becoming interesting. Do we have Santa skills? who is naughty and who is nice. And it appeared we can. So we can actually we can decide who should be on our peering list on the right and who is on our list on the left. So what we did is we actually created a database with every AS that had listings. We uploaded the aggregated number per AS, and we find those at Shadow Server. And we got aggregated numbers, open resolvers, NTP servers, jargon, SMTP, SSDP, everything per AS. And then we actually started pounding on the API for RIPE for how many IP addresses are they announcing from that API, from that AS number. And I have to give some understanding here. It's a high naughty rating does not mean it's a bad peer. It just means that they don't know yet. Because we've spoken to networks in the Netherlands, for instance, and asked them about their rating, and they said, well, we run a good help desk, good abuse desk, nothing is an issue in our network, until we actually asked them to look at this. And they said, I didn't know I had so many open resolvers. I didn't know I had so many NTP servers participating in DDoSes. And because nobody told them, they never started looking for them. And the interesting thing is, you don't have to look for them. Because if you ask nicely for the guys at Shadow Server, they will tell you on a day-to-day basis. The only thing is, if you want to do something with those reports, it's probably easier to automate your abuse messaging. So those ratings can actually be improved. And that's actually what some of the customers also asked us. They asked us, yes, we don't mind if you include us or our ratings in this particular presentation. And by the way, how can we improve our scorecard? Because this is going to be interesting. We want to rate better than the other AS number on the same presentation. So if you look at some of the Dutch networks that I've listed here, this is actually a query that we did on the database. You have an AS number here, an AS name, the M6 organization. In this case, we're actually, we're looking at this for M6. So we just included the whole M6 list. And here is the naughty rating. So basically, it's a rating system that's based on the announced IP addresses. And then how do you score? So we have NTP servers here, which is 63 on this particular network. And NTP has a specific amplification factor. DNS has a different amplification factor, and so does Chargen and SMTP. So in the back, before the rating system, the rating of the amplification factor actually is included in the rating. So that actually certain vulnerable servers have a higher impact on your rating. And also because larger networks, you can actually have more vulnerable servers. So it basically gives a very good weighted system. So have a look at here, Triple IT. I'll get back to them later. 9.5. And typically our cutoff rate for being on the naughty list is a 1. So if you score higher than a 1, you become a discussion topic. And basically we say, we should actually look at how traffic ratio is, and is it actually worth having this customer or this peer on our premium peering port? Is it worth the hassle that they might inflict upon us during a DDoS? And that's how we're looking at peering currently, which is different than just traffic ratios. So this is the results for SurfNet. Kudos to them. And this is the view from our partner portal. where we actually just made it very easy for customers of us that want to do this. And this is something that we will actually present in a specific website to the public as well. So we will open source the data, and we will provide this where you can just, same as here, put an AS number in and get the results. So that will actually make it easier for peering managers to review who they're actually engaging with. And on the interface, it will actually state, in the pie chart, what the actual numbers are behind it. It's not just a pretty picture. Ratings is here, 0.16, announced IPs, and when the last update was. Okay, so how to improve? Like I said, Abuse.io, it's free and open source software. Very nice to automate your message parsing and event handling. I can definitely recommend it. I've given a presentation on it on the Abuse Working Group last RIPE meeting. They're doing a ton of development. I can definitely recommend doing this. And then, not to forget, get your own reports at Shadow Server. The URLs here in the presentation. If you need to look in, really look and search for it on the Shadow Server website. But if you just look this URL, there is an email address where you can just send an email to, and they will, include this to you. The presentation here says there's a backlog. They've actually put aside resources for all your requests. So within 2 days, all your requests will be processed. So they've said, tell them on stage, we'll make this work for them. Okay. So on the Naughty port, we can explain how this works. If you want to do this, if you want to improve your rating, or if you want to have a port like this on AM6 yourself, we can tell you how we did it. We can provide the data so that you can actually make your own decisions. Who do you want on your Naughty list? This may not work for everybody. This may work for us, but this may not work for somebody else. We have a very Dutch-oriented customer base, and we do not have a lot of international, geographically diverse traffic. So we don't do a lot of traffic to Ukraine and Poland or Russia or China. So for us, it's easier to compartmentalize certain networks and do not have an issue with that. That may differ for different parties. However, this may actually work for you as well if you're in a similar situation. All you need is an extra M6 port, extra AS number for now, and you can decide for yourself. So TripleIT actually did the work, and they're actually now down to a single DNS server from a customer, and their rating is currently 0.00753. So they're actually running currently from the top of the list, 9.5, in a couple of slides back, to the cleanest network in the Netherlands from this point of view. So kudos to them. Next up is we're actually planning to publish this information on the website. We're also looking into adding additional amplification factors to include in the rating system, like TFTP, because that's not in there yet. And we want to have AS sets as well, so that you can not only look at the announcing or the peering AS, but also at the AS set that they are announcing it from, and see the top 30 from those ASs. And that's it. Any questions?
Thank you very much, Erik. It's most informative. So, please.
Hi, Ronen from the RIPE NCC.
Just got to get the mic going.
Oh. Hello?
Yep.
Okay, Ronen from the RIPE NCC. I have a question from a remote participant named Sasha Luke. He's asking, isn't the EU net neutrality directive specifically designed to prevent these shenanigans?
No, because during normal operation, the 1 gig traffic is enough for, the 1 gig port is enough for normal operation, because typically we do like 10 or 20 meg to those peers. So normal operation, it's not an issue. It's actually during a DDoS when we get 70, 80 gig traffic, that's when it fills up. But then my regular port would fill up anyway as well. So, and if you are allowed also under EU regulation to act on abuse. And DDoS is in that regard is abuse.
Thank you.
Yep.
Have you looked at doing this with...
Sorry, can you state your name?
Oh, sorry.
Affiliation,
Avi
please.
Friedman with Kentic. Have you looked at doing this with transit? In the old days, people would get a T1 to someone they didn't like and put their IRC server on it so that all that traffic would flow that way. But some transit providers will allow you to, with communities, say, make me closer to or farther than these people. So you could pad sort of all your peering and, ironically, make yourself shorter through some transit connections to people you couldn't do this with because you can't peer with them.
Yeah, transits, there are multiple options to do that. You can look at flow spec. You can just null route traffic more than 500 kilometers away from you. There are several options. You can even null route your traffic through your transit provider and still have your internet exchange filling up your complete backbone. So this particular option is specifically for internet exchanges. But we're also obviously looking at what kind of garbage is coming in from the transit, but that seems to be a less of an issue.
Thank you.
Alex Mnyaka, Curator Labs. I just have an addition to your list of the tools, and just maybe useful to know that we have our radar tools. It's absolutely free, and anybody who authorized himself through RIPE database can check all vulnerable services in his autonomous system, all amplificators, NTP, DNS, TFTP, and check autonomous system before connecting to AMSA X or other X. So probably it's useful to know that there is such possibility.
Sorry, so you want to have everybody?
It's possible for everybody to check their autonomous systems for vulnerable services before connecting to the AX.
It's actually public data.
What's going on inside.
Yeah. So the information that we use is public data, but only the aggregated data. People that want to have an impact on their own network and want to see what's in there, they can request that data from the shadow server guys. They actually have the detailed data per IP address. We're not looking at that. We're just looking at the aggregated data per AS.
Exactly. You are looking on aggregated data. But
yes.
Somebody who wants to use your service probably want to understand what's going on in his autonomous system, and our tool provide this possibility.
Okay, so that data can be requested from shadow server for free.
Yes.
For
free.
Okay.
Absolutely.
We really need to move. If it's a very quick question, then yes.
Yes.
Sorry. No, the gentleman behind you, I think. Sorry.
Mikkel Christensen, one.com. My question is, do you have any problem with the BGP to the router server going down when you have attacks?
Yeah, because during the DDoS attacks, we don't have an issue keeping them, the sessions up to the route server. That works fine. No.
Okay, thank you very much, Erik. So now we have 3.5 lightning talks, which will all be very quick. And up first we have Phil Roberts.